Welcome everyone. Welcome to today's webinar on topic automating schema and data migration using RosettaDB and Kinetica, enhancing efficiency and accuracy. So I'll start with a presentation of the background on things that we are going to demonstrate, and we'll have some slides, and then we'll continue on the actual demo on showing to you the data product which solves the problem that we are going to mention today. So the agenda for today is going to be as follows. We'll have an introduction. We'll say a few words about RosettaDB and Kinetica database. Then we'll jump on some keywords about understanding schema and data migration. Continuing with benefits of automation, some best practices and use cases. And finally, we'll have a demo to show how all of these things work together and the final data product that we are going to demo to all of you. The final part of today's webinar will be mainly questions and answers. So as Tony said, for any question that you might have, please write in the chat, and at the end, we'll be able to cover all of them. So we start with the very first part, what is Kinetica, and I will ask Harry to continue to give us some introduction about Kinetica.
Hey everyone, so Kinetica is the world's only fully distributed GPU database. So what that means is that we can apply the massive scale, massive parallelization that is offered by the GPU at scale, right? So to solve really big analytical problems. So that's a key differentiator in the case of Kinetica. And there are many capabilities that we offer, but the few that I want to focus on are these three which are listed here. The first is handling real-time data. So because we have a distributed architecture, we're able to ingest a lot of real-time data in parallel across different nodes simultaneously. And that's a key capability that we have. The other piece is the GPU acceleration. So because we are a GPU accelerated database, and we've been building on top of the GPU for more than a decade. And this is not a simple port of an existing database like, say, Postgres. We've built all the database kernels from the ground up. So what that means is that we've been able to, at a very deep core level, harness the parallelization that is offered by GPUs to really accelerate computing. So we can execute really complex queries. So we have spatial functions that you can run on Kinetica, time series functions, graph analytics, and regular OLAP analytics that you can run on Kinetica, but they harness a massive parallelization that is offered by the GPU, right? So think about real-time data that is coming in and being able to execute at scale, like large amounts of real-time data at high velocity coming in, and being able to execute really complex queries on top of that data to return results within seconds, right? That's a key differentiator. So the place that we are seeing a lot of emerging interest in our capabilities is also in the generative AI space. So one thing, I mean, we all know what ChatGPT does, and like say also some of the emerging use cases in the Gen AI space, right? But one of the key capabilities that is still missing in that stack is the ability to process a lot of data to feed that information back to the large language model, the LLM, which can then contextualize that for the user, right? So because that requires the ability to run some sort of analytics on that large amount of data in real time, and then give the results back to the LLM in a way that it can process and give back to the user. So think about a conversational inquiry of data, right? So you're asking questions of large amounts of data, but just using English. Now we've seen small plays on this where people have 1,000-row data sets or something like that, and you might execute some ad hoc analytics using Python or something like that. But we are talking scale, right? So think about billions of rows of data. And so this is where our capabilities really fit in, because we are able to execute these queries really fast and power these conversational inquiries of data. But that's a very quick overview of what Kinetica can offer. But when you think about Kinetica, think about speed at scale and real-time data. That's what we do.
So thank you, Harry, for the introduction and description on what Kinetica is. And that's the reason why today's purpose of the webinar will be to see how we can actually migrate data objects and how we can migrate data to Kinetica. And the final outcome would be how we can synchronize a Postgres database to a Kinetica database. So before moving to the demo, let's see what RosettaDB is and how we are going to achieve all that thing that we already introduced at the beginning. So RosettaDB is an open source tool. It's a declarative data modeler and transpiler that converts database objects from one database to another. It allows you to define your database in DBML and then RosettaDB can generate the target DDL for you. So all it does, it utilizes JDBC to extract schema metadata from various databases, and then be able to generate the DBML models for you, which then can be easily converted to alternative database targets. Like in our today's case that we are going to show, we are going to convert the Postgres database object to Kinetica database object in order to synchronize our Postgres database to Kinetica. So it is easily embeddable CLI for CI/CD pipelines, a use case that we are going to demonstrate today. It acts as schema translation. It also is integrated with Git. You can integrate all your schema translations, all the DDLs and DBT models generated out of RosettaDB directly to your Git environment, regardless whether you use GitHub, Bitbucket, GitLab, and so on. And at the same time, one of the main functionalities of RosettaDB is also that it can act as a testing framework for your data products, for your data across various databases that you have. So it gives you the ability to check the quality and integrity of the data as part of various integrations that you might have during your daily activities as data engineers. So this is RosettaDB as short description and how we are going to utilize RosettaDB as part of today's use case. Moving forward, the next focus will be to understand some keywords that we are going to mention and things that we try to solve as part of today's webinar. So what is schema migration, and understanding the change schema capture and how RosettaDB resolves this. Schema migration means migrating database objects from one database to another. And one thing that is very common nowadays is that schema changes over time. As part of your daily operations, as part of the databases that you have, your database keep evolving. New tables get introduced, new data objects are there introduced, some of them are getting dropped, and so on. So things are changing. And with the help of Rosetta, the goal will be to track those changes and be able to migrate those changes from one database to another. So that is the first point that we are going to cover. In addition to that, as part of the data migration, that means mainly my data migration is moving actually the data from point A to point B, and depending on what is your target system, target database, and for what purpose you use that, whether it's going to be OLAP or OLTP, there are different attributes to take into considerations, like the frequency of the load that you want to perform and the size of the load of the data that you want to move from one point to another point. And we are going to solve the process of data migration by using Kinetica's KISQL, the CLI tool, on today's demonstration. Today, there are available many tools and options that allows data engineers to perform these processes, schema, data migration. There are offered options like ETL, EL, ELT, and the goal for data engineers is always to try to simplify these processes as much as we can. So end up automating all those things where you have a single product which does the schema migration for you, the data migration, and at the end you also have the testing which does the data quality checks in order to guarantee and make sure that the data that you move from one database to another actually meets all the requirements that you had and all the accuracy that you require. So moving forward, some of benefits that actually come as a result of all this automation of these platforms. First, we have governance. Since all this solution sits on top of Git, and with the help of Git, we have those version control capabilities. As well as the CI/CD capabilities, it gives us the opportunity also for the data products to be able to manage different environments at the same time, like having dev split and separated from test environment, or separated from stage and production environment. So those are some great benefits in terms of automation related to governance. In addition to that, using this type of solutions also gives you efficiency gains, because all those transformations and translations are done automatically, which gives no need for manually intervention and handling them manually. And since RosettaDB also can act as a test framework, it has another benefit, which is error reduction. So in order to check the data integrity, you don't have to go and manually validate everything. Everything can be part of the same pipeline. And finally, since everything runs on top of GitHub Actions, CI/CD, this gives you the capability of scalability, which gives also you the opportunity to be able to schedule them, do ad hoc runs of various pipelines whenever you deal with this type of data products and synchronizing source database to a target database, which in our case is Kinetica. So streamlining database operations and some tools and technologies for automation, the ones that we consider the next generation of data ingestion tools, Git and CI/CD together have been there for decades. So software engineers do use Git for version control. CI/CD is there for continuous integration, continuous development and delivery for various software engineering products. But the same thing can be also utilized for data products. And that will give us the ability to version control the changes of the schemas and data objects as part of our databases, and at the same time, with the help of the CI/CD, to automate and orchestrate the process of synchronizing two databases as part of this process. With the help of RosettaDB, we can also perform change schema capture, since during daily activities, the database keeps changing and new data objects keep evolving and introducing to the system. With the help of RosettaDB, we can capture the deltas and the differences between different database versions. So in order to ease the process of migrating from one database to another, especially whenever we want to perform data engineering tasks like ETL, ELT, or EL, when it comes in place to load only the necessary data that got changed or got added recently as part of our platform. Finally, the data integrity is something that will give us the ability to check if the data is correct after we moved from one source to a target system. So the most important thing is choosing the right tool in order to be able to achieve all these goals. So with the help of version control and tracking changes, everything can be orchestrated, and with the help of the CI/CD, we can create and manage migration pipelines where RosettaDB and Kinetica can help us migrate schema, migrate data, and finally be able to test all the migrated data and the quality and integrity of the data that we have migrated to our Kinetica database. All these things can be automated. So you have synchronization pipelines that will work there and do all the jobs for us. Some use cases and best practices that we recommend as part of this process is that we'll use GitHub in our case to deploy our data product, and use the GitHub Actions and the CI/CD capabilities in order to orchestrate the whole process. And the migration process, the schema and data migration process, will be done in 3 phases. Phase 1 is the place where we map the schema with compatible data types. This means that we read the data objects from Postgres as a source system. Using RosettaDB, we extract all the metadata and all the schema from Postgres database, and we convert it to Kinetica by taking into account, in order to match the compatible data types and the differences that we have from Postgres to Kinetica database. And phase 1 will be mainly migrating the schema. Whatever data objects we have on the left, which is the Postgres source, we create on the right, which is going to be the Kinetica target database. Phase 2 is migrating the data and moving the data with the help of Kinetica, KISQL, the CLI tool of Kinetica, which after the schema got created, we simply can utilize Kinetica's KSQL and JDBC connection to the source target, to the source database, and move all the data to the target database. And phase 3, again, with the help of RosettaDB, we can check the data quality, and we can run some tests against the data that we loaded on the Kinetica database, just to make sure that everything is okay, is accurate, and we can continue with further analytics and utilize all the features and functionalities that Kinetica database is offering. Then phase N means that you can repeat phases 1 to 3 multiple times in order for incremental loads, and make sure that for every new data object that gets created, then those will get migrated as well, including schema, data, and finally performing quality checks, and all that process can be orchestrated with the help of GitHub Actions as part of our GitHub project that we are going to demonstrate. And finally, you'll have a data product, where you can simply perform some A/B testing on top of the data that you have already moved. You can have automated deployments, and you can start to split between different environments in order to decide how you want to handle the part where you deploy things in dev, test, stage, production, and so on. So that was some intro related to what Kinetica is, how RosettaDB is going to help us as part of this process, and how we can utilize Kinetica and RosettaDB in order to perform database migration from Postgres to Kinetica with help of RosettaDB and Kinetica. So now let's go and jump to the demo and see how all of this work in action. First, we'll start. I want to just show the first part is everything that we are going to demo today is part of this public repo, RosettaDB Postgres to Kinetica, and the whole data product is located here. So as part of this repository, we have all the needed configurations that you need, including RosettaDB, KISQL, and JDBC drivers in order to perform Postgres to Kinetica synchronization. So everyone who is interested to do this type of synchronization and want to use the same product, here you have a short README which tells you exactly all the elements that are part of these projects, and some how-to in terms of starting, forking the project, and using this project for your needs in order to perform the similar tasks. In order to use this project as part of your environment, you will need to perform only 2 steps. Fork the project, it's completely public, and then make sure you go in the variables and secrets and update it based on your configurations, because at the moment, all the variables and secrets here are pointing to my environment, which I'm going to use for the demo today. So this is where everything is located. Now, moving forward, to tell you more about what are the elements and items that are part of this project, I'll simply open this data product with my Visual Studio Code, just to show you all the necessary items and how we have put all the pieces together in order to make sure that this synchronization will work as expected. So at the beginning, we have under GitHub Workflows directory, we have a main.yaml, where here we have a configuration of the pipeline, which is made of 3 jobs with a couple of steps under each job. So the goal of these 3 jobs is to perform those 3 phases that we demonstrated in the slides, which is Rosetta schema migration, job number 1. Then we have KISQL loading data, moving data from source to target, and finally Rosetta data quality check. I'm not going to go into details about all these steps right here, but this is the pipeline made of 3 jobs where we initialize Rosetta, we configure Rosetta, KISQL, and you configured all the JDBC drivers and everything that we need as part of the project. And then on the first part, we simply migrate the schema. As soon as the schema is done, then we continue with migrating the data. And finally, we run some tests, and we are going to show you how we write those tests and where those tests are located. As part of this project, we also have the drivers. Since our use case today is moving from Postgres to Kinetica, we have the necessary JDBC drivers, the PostgreSQL JDBC driver and Kinetica JDBC driver. You already can find here the KISQL, the CLI tool of Kinetica, which will perform the data load for us. Right here we have the Rosetta and the binary for Rosetta. Everything is configured for the Rosetta. You simply clone the project. Rosetta will be available here. And this is the Rosetta used for Ubuntu, because in the GitHub Actions, we run all the workflows in the Ubuntu. Besides that, we do have the main configuration, which provides us the necessary information to connect to the source database and target database. But as you can notice here, all the items here are configured through environment variables, which are read through the variables and secrets from the GitHub project that I just showed before a couple of minutes. Under the test.csv, we have a CSV file where you can define various testing rules in order to check for the accuracy and integrity of the data after the data load is finalized. So for the example that we are going to use, first I will migrate a single table, then we'll add some additional tables, do more migrations. Here we can write as many rules as we want for various tables, for different columns, and the values that we want to expect, and what is the expected counts for those specific columns for the table that we are migrating, in order to check that everything matches the accuracy criteria. And before getting into action and starting this pipeline, another thing that I want to mention is that RosettaDB, as an open source tool, it uses a translation matrix in order to map and translate from a source database to a target database. And since different databases have different column types, and in order to make sure that you make that translation properly based on your use cases, as part of RosettaDB, you have all those column types mapped. However, at the same time, with the help of RosettaDB, you can use custom translation, which means that you can get what RosettaDB is offering, and you can start to customize the translations based on your needs. For instance, in Postgres, you may have a data type, which might be something custom, and you want to map it to a Kinetica to a string based on use cases and based on the requirements and business rules that you might have at that moment. So with the help of the translation.csv file that I'm showing right here, you can simply extend or modify the translation capabilities that are offered by default through RosettaDB. So this is very powerful, because this gives you the ability to match and do translations from one database type to another database type very easily, and matching your business rules and requirements. So this is the whole project, and taking the same project and only customizing the variables and secrets, you should be able to use the exactly same project in order to do with the migration processes. At the moment, for the purpose of this webinar and demo, we have one Postgres database currently holding only one table, New York City taxi, and I'm going just to show some details around this table. So in our Postgres database at the moment, we have a single table. This is New York City taxi, one table, which has 19 columns with in total 500,000 rows. And let me see, yeah, we have already configured all those. The user is RosettaDB owner. So this is one table currently that we have in our Postgres database. And if I go to the Kinetica, I have a Kinetica now running in the cloud. I go to my default schema. So far, I have no tables. I have nothing here. If I want to start the migration process and the synchronization process, all I have to do is I must make sure that everything is configured properly under the secrets and variables of my GitHub project. And right here, I just made sure before the webinar that everything, the Postgres database host, the Kinetica URL are pointing to the right hosts and URL that are currently running and that I have access to. And I can simply go under my actions, find my main workflow, which I just demonstrated, and I can click Run Workflow. So as soon as we run this workflow, this is going to have now 3 phases. Let's monitor it, and while we monitor it and see what is going on after every phase. So the first step of this workflow is Rosetta schema migration. So here, as part of this workflow, we have a couple of steps. We initialize Rosetta. We do compile or transpile, which is we connect to Postgres database. We capture the schema and all the data objects that we have currently in Rosetta in a Postgres database, and we convert them to a Kinetica DBML. So this is translation process, which actually converts the data objects from one database vendor to another. Once that transpile and compile process is finalized, the next step is we continue and apply those changes. By applying those changes means that everything that you have converted, all the data objects that you have converted from Postgres to Kinetica, and all the data objects that are not present in Kinetica, Rosetta should be able to create them and then push all the changes and metadata that it created as part of this process. So the first step already finished. If I go back, phase number 1 is done. And while phase number 2 is running, loading data, I can simply just go here quickly to Kinetica, do refresh. I should see the table already created here. Yeah, New York City taxi now is already in Kinetica. Moving back to my pipeline, now we wait for step number 2. Step number 2 is actually loading the data. And now with the help of Kinetica's KISQL, we simply connect to the Postgres database through JDBC, and we'll load all the data for the new tables that got created on the previous step. So when this is finalized, it looks like KISQL is finished within 32 seconds. Let's go here to see what it actually loaded. So if you are already familiar with Kinetica KISQL, since there was only a single table created as part of the Delta that we just showed, it will simply load into New York City taxi in Kinetica, select everything from our Postgres database using the data source of Postgres, and as a result, we should see 500,000 rows moved to the Kinetica. And after that part is finished, the third step is actually going ahead and running those test rules that we already had in that test.csv file as part of our project. So the test that we have checked here is that table got created, data is moved, and now we go ahead and check whether for the vendor ID, for the value New York City or NYC, we have in total 148,750 rows, and this is a pass. Then we checked for a vendor ID again, then we can check for passenger count, and you can run as many tests as you want just to make sure to check for the data accuracy after the data has moved to the Kinetica. So this was how a single run in order to synchronize Postgres to Kinetica looks like with the product that we showed, which is currently located in GitHub. However, let's go to Kinetica, make sure that everything got created properly, and after that, see how we can use Kinetica in order to do analytics and bring introduce some new changes in our Postgres database to continue and have additional runs of this pipeline. So if you go here, click Info, we can see now that in Kinetica, a new table got created for us, and that was as a result of the translation that happened. And here we can see all the data types that were used as part of this translation and how the new table looks like based on the translation metrics that we showed. At the same time, we can preview the data in Kinetica. And right here, we can confirm that it looks like all the 500,000 rows are already now available in Kinetica. In terms of the quality of the data, we had only 3 rules there. We can extend that as many as we want based on the needs in order to confirm that everything that got moved to Kinetica does meet our requirements related to accuracy and integrity of the data that we are working on. However, once the data is available in Kinetica, then you can start to use all the features and capabilities that Kinetica is offering, like you can start and build some dashboards for analytics purposes. Since the data set that we moved also has geospatial data, I can simply go ahead and visualize all the points about various pickup and drop-off points, and I can start to perform analytics and use all the features and functionalities that Kinetica is offering with the data which I just loaded from Postgres. So this is phase number one. This is step number one. Let's assume that your Postgres databases keeps changing, keeps evolving. And as part of your Postgres database, you can have more tables, or on the actual tables, you can drop some columns, or you can insert more data and so on. So in order to simulate such a scenario, I will simply now go ahead and create some two very simple tables in Postgres. So let me go quickly in Postgres. And let's bring up some tables. I'll create a table customers. I'll create a table payments. I'll insert some data there. And at the same time, after I create these tables, I'll go ahead and drop a column in my actual table, which we just migrated from Postgres to Kinetica. So I'll run this. Okay, alter table. Okay, let's get back to this after that. Let me run. So the number of tables that I have here now is I have 3 tables, and I have some additional data in my Postgres database. In order to make sure that the schema has changed and the schema is has now a new version, let me go ahead and make sure that I can capture those changes, and I can see actually what's going on here as part of this change, which are the new tables that got created. So with the help of the RosettaDB Enterprise version, I can also visualize the schema evolution and all the changes that I have from one version to another before migrating them from Postgres to Kinetica. So let me see for the demoing part that we have now. So we used to have version 1 of our database. Now we have the second version, which has some delta. And the delta right here between 2 Postgres versions, which I just demonstrated today, is that I used to have only New York City taxi with all the columns, and now I have 2 additional tables, which are customers and payments, one of them having total 4 records, 5 records here. And the goal is to see how we can use the same data product, the same GitHub action workflow, in order to continue with the synchronization process and to move for us only the delta when it comes in terms of schema, data, and finally performing the tasks that we require. So this is how Postgres has changed. So if we want to synchronize now whatever we have in Postgres here and replicate the same in Kinetica, all we have to do is just go back to Actions, find the workflow that we are working on, and just run the workflow, which is meant and organized for, which is designed in order to do all this synchronization process in 3 steps. So while this is running, I'll get back to my Visual Studio project and just pinpoint one more thing. You can also go ahead and completely automate this process. Instead of me going and clicking there, I can schedule this to run every 15 minutes or every hour, every 24 hours, once a week, or whatever I want. So it will go ahead and, as Postgres, with the help of RosettaDB, give me your current schema, generate the DBML out of it, convert it to Kinetica, and during apply process, apply only the differences and the delta that is new compared from Postgres to Kinetica. So this way, scheduling this workflow, you will have a complete A to Z integration without worrying at all on what changes are getting performed in Postgres. You simply just synchronize them with your Kinetica database, and you have all the data directly available in Kinetica. So let's see whether this is still running. Yeah, in 29 seconds, it did the schema migration. Now it finalized also the Kinetica data load. Now it continues with the data quality check. We are okay on the data quality check as well. And if you want to run just specific parts of it, you can simply run that. If you want to automate only the data quality check, you can as well do that. So this is something that you can integrate as part of your platform based on the needs and best practices that you want to have. So now A new run of the pipeline just got finalized in 1 minute and 29 seconds. In order to confirm that everything is okay, I'll simply go to Kinetica Workbench, refresh it, and as you can see now, I have more tables. I have the Delta also integrated here with the data, with the schema, and my Kinetica stays synchronized with all the changes that I'm introducing in the Postgres database. So related to this, we can now rerun the pipeline as many times as we want. All we have to do is we simply need just to go ahead, introduce some new changes, and rerun the pipeline. If you rerun the pipeline without any changes at all, it will simply notice there that there is no difference, no need to create or drop anything. It simply just continues with the state of the database in Kinetica as it was before. So related to the final, as part of the final step of this demo, I also want to note one more detail. If we go back to this pipeline workflow, here you will notice that at the end of every job, we do commit and push some changes. The same happens for schema migration, the same happens for data load, and the same happens as well for the data quality check. This way, the project that we have right here, the one which is public that we introduced at the beginning, you will see that for every new version that it created in Kinetica, we have all the states already stored here. So if you are interested to see which was the last model, RosettaDB DBML model, that RosettaDB used in order to create all the tables in Kinetica, we can simply go and check this model.yaml, which is already available here. Besides checking the model.yaml, all data objects and all attributes there, you can also notice here all the tests that got appended as part of this process that are actually running at the end in order to check for the data quality. If you are interested to see which was the actual DDL SQL code that got executed, here you can go and just find it. You have the timestamp when it got executed, and this is the last thing that we created. If you come from the DBT world, you can also go and find and extract as well the DBT models as part of your project. So this is something that will keep created for you, and every new version of model.yaml, DDL scripts, DBT models will get pushed on the project that we just introduced as part of this GitHub repo. The same does apply also for KISQL. So if you are interested to know exactly what Kinetica was using in order to do that data synchronization, for the last pipeline run, it simply found out that there was the Delta was only 2 new tables. It copied everything from customer and from payments table, and it moved back to the Kinetica in order to perform that step. If you want to introduce more tests, and on the next pipeline run to have additional test coverage and to do additional checks on top of the data accuracy, then you simply add more rows as part of this CSV, matching the criteria that are already here to check for various columns and so on. And that's it. So we've successfully synchronized data from PostgreSQL to Kinetica using our GitHub project with the help of RosettaDB and Kinetica's KISQL. So this project ensures that our data is up to date and accurate across both databases. So thank you all for the attention as part of this demo. And I would love to use the remaining time now of our webinar for questions, discussions related to today's topic.
Hey, Nuhi, I have a couple of questions. This is Hari, by the way. Let me turn my video on as well. Yeah, so the first one that I have is, does this work with tools like Airflow, for instance?
So you mean the wall integration, like every?
Yes, yes.
Okay, so since Airflow is a generic orchestration tool, then in order to make sure that this works with Airflow, you simply only need to include Rosetta and KSQL as components as part of your orchestration pipeline that you have in Airflow. Since GitHub Actions, probably you have noticed here, are very similar. GitHub Actions here played only the role of orchestrating the whole integration and split all this integration in 3 phases. So any generic orchestrator can invoke a self-contained binary, should be able to orchestrate such a pipeline. Like simply, you need to integrate Rosetta, KSQL, configure them, and the answer is feel free to use Airflow as well.
Got it. I have another question, which is around, so we don't use GitHub, we use GitLab. Does this work with something like that as well? Could I use CI/CD pipelines and GitLab with Rosetta?
Since GitLab also provides CI/CD pipeline configurations that you can define in YAML, then you simply would include Rosetta and KSQL as jobs in that pipeline, and they will execute in very similar fashion. Not only GitLab, you can also use other CI/CD and workflow solutions, including Bitbucket pipeline, Jenkins, Dexter, Airflow, the one that already we mentioned, and many, many others. For the purpose of this demo, we intentionally use GitHub Actions because it's a bit more simple and straightforward to configure and visually represent, much user-friendly for engineers. So anything similar to this that allows you to use CI/CD and workflow is a Go solution.
Yeah. So I think you might have mentioned this already, but so this one is using Postgres. What if we wanted to use some other databases as well, say something like BigQuery or some other similar databases?
So at the beginning, I didn't spend much time. When I explained RosettaDB, I said that, yeah, we support schema translation and change schema capture for various databases. And it's not only Postgres and Kinetica, the supported databases. So if you go to the RosettaDB GitHub repo, you will find that there are other databases. The most popular databases are already supported by RosettaDB, like BigQuery, Snowflake, MySQL that you mentioned, Postgres, Kinetica, then SQL Server, DB2, Oracle. And as soon as you use CI/CD, since as soon as you RosettaDB uses JDBC, then you can simply have any database that supports JDBC as part of this integration.
And I'm guessing that goes for the target database as well, right? So you can use instead of Kinetica,
definitely. So all the databases that I mentioned, even though today's webinar was mainly Kinetica as target database, no, you can have BigQuery as target database. You can have Postgres to Postgres as well. You can have MySQL as target database. So all the list of supported databases is the ones that you can use as part of the integration.
And I guess my last question, as I was watching the webinar, was also, who are your primary competitors, or what are the, let's say, I've heard of things like Flybase, and Liquidbase. How is this different? How's Rosetta different from those type of solutions?
Oh, okay, that's a very good question. We already have a blog in Medium that you can find where we describe the difference between RosettaDB and Liquidbase. So while you mentioned both of them, while both Liquidbase or Flyway are also viable options for schema management, they place a burden for state management on the end user. So as I explained at the beginning, Rosetta is a declarative database modeler. It works by converting a schema to a DBML, which is a generic model that represents the state of a database at a given point in time. And the model can be extracted from pre-existing databases, or it can be created from scratch, or it can be created as a result of the conversion that you do. That's something that offers Rosetta that you don't have in Liquidbase or Flyway. So Rosetta uses the model to bring the database to the declare state, as is defined in the DBML. Therefore, the end user with Rosetta doesn't need to care about the necessary DDL or DBML in order to bring up the database to the preferred state, as we saw in today's demonstration. So we were moving from Postgres to Kinetica, and Rosetta was extracting all those data objects to a model.yaml, which is the declarative state defined in that DBML for our Postgres database. Once that gets converted to Kinetica, then Rosetta handles the DDL that I showed in the GitHub repo that gets executed automatically in order to create those data objects.
I also see a question on Q&A. I can read it out. What is the optimal timer to set if you decide to do an automated pipeline run, depending on the size of the DB, having in mind the optimal speed of the runtime?
So that's something, it definitely depends on the use case. It will depend on the database. It will depend on the various scenarios that you have. Sometimes when you say the optimal timer, it's something that definitely will get, the answer will be on the use case and the business logic that you want to target as part of the data product that you are building. And always keep in mind, because sometimes with GitHub Actions, you may hit limitations, as well as a limitation in terms of the number of hours and minutes that you can use, the limitation in terms of the machine where all this infrastructure gets run. Currently, we use the most basic ones and so on. So try always to consider similar solutions with other alternatives that we already discussed with Harry, like Airflow or Jenkins, or things that are more production ready if you don't want to use these free things for POCs and stuff.
Yeah.
Okay, any other question? I don't see any other question here in the list. So thank you all for your attention. I hope you find this valuable, useful, and if you have any additional question, just feel free to contact us related to RosettaDB and Kinetica. So right here, you can find some information about the GitHub project that we use for the webinar. Feel free to take it as an example, fork it, and start it from here to do experiments. You also can customize the process of the translation there. In order to start Kinetica and start playing with Kinetica Developer Edition, just follow the steps here. All you need is just have Docker installed in your environment, and you can bring Kinetica and start use all these capabilities. For more information about RosettaDB and its documentation, just follow the links as part of this slide deck. So thank you again, and thank you for joining today's webinar and demo.